What is forensic science?
It's the application of science to the law. We do a lot of death investigation here. We respond to any death in the county that's unattended, which means there's no doctor present or no doctor willing to sign. So we deal with bugs a lot. In Florida, a body decomposes very quickly. So these bugs show the different stages, essentially, of death. So depending on what bugs you're looking at the crime scene at that moment, you can determine time of death within a certain time frame. Like I was saying earlier, this blowfly is the first bug on the scene, and he's there within seconds, laying eggs, which then become the maggots. And the maggots then go through different stages. So depending on what stage your maggots are, is how long that body's been down. But here in Florida, a body can skeletonize in August, 3 days. It's amazing how quick.
Do you see any relations between forensics and chemistry?
Oh, definitely, yeah. Most of what we do is related to chemistry or a science in general, in every aspect. Chemistry, like even photography is chemistry. You know, I mean, if you're developing film, even that's chemistry.
And now we're using this equipment for identification of biological fluid, different kind of chemicals, fibers, hair, which previously been chemically treated, everything basically.
How does this process relate to science?
It's more like physical sciences, because when we illuminate any surface with this light, we actually bring energy to electrons, and excitation of electrons cause emission of different kind of lights. Usually it's invisible light, but with when we're using different kind of filters, we can see this light. And I'll show you this on the wall, for example. Now you can't see anything. Using this filter, I'll show you what you see. Not like that.
Here it is. Yes. Oh my God.
Exactly. Special substance on the wall. Absorb this light and emit different kind of light, which is invisible for normal human eye, but with special cut of filters, we can remove all additional lights and just see this beautiful yellow glow on the wall. This machine works for any kind of chemicals. Some of the chemicals, for example, chemically treated fibers, chemically treated hair, any biological fluid, blood, urine, saliva, semen. So in other words, we're using this equipment to find and identify substances at the crime scene.
What chemical reactions are used by forensic scientists?
There's chemical reactions, heat reactions. We have all different physical reactions. All different kinds. It just depends on what you're using. So. That's kind of a vague answer. I don't know how else to answer that. This is fingerprint processing for porous items.
Okay.
So what we use here is a chemical called anhydrine. There's several steps you can use to process something that's non-porous. This is one of the fastest. If it's a very, very important crime, we'll go through every phase. But I'm going to show you this so you can actually see the reaction. This is called an anhydrine. And what this chemical does is it reacts with the amino acid that's deposited by the fingerprints. It's actually pretty amazing. We just developed a fingerprint on a paper towel. It was like a miracle. But it does happen. So basically what you do is you take a porous item. You can see that this is actually evidence from a real case here. We do stuff like that in here. And you just spray it. I'm going to soak it through. Once these do develop, they'll turn like a purplish color, and that's the reaction, the chemical reaction between the anhydrine and the amino acid. Okay. And once you develop it, you're going to put it, in order to expedite the process, you're going to heat it. So we can either put it in this, which we call an incubator, or if we're in a rush and the detectives really want an answer, we'll use the hairdryer, and we'll just heat it up that way. Once you've done that and you have your print, you want to scan it or photograph it because it will fade away. Or you can put a fixative. Here it is. Spray that on it, it'll turn it red, and then it'll be there forever. This one would erase it. So say you had a really important document, someone's birth certificate, and you have to process it. So you process it with anhydride, but you get no latent prints of value on it, but there are marks on it. You would use a clearing solution and erase the marks. So then their birth certificate would still be useful to them. So we'll use the hair dryer. Normally I would probably put it in the tank, in the incubator, and let it sit overnight. That's normally how we do it. And sometimes with anhydride you have to do it a couple times. It just depends on how much of the amino acid in your fingerprint has been deposited on the paper. It's starting to develop. You see them? There's a pinky finger there. There's the top of a palm. This is actually a reaction with the amino acid. Rather than staining it, it's just reacting with it. And that's what we would use to make an identification.
How do these reactions help you to do your job?
Well, they help us catch the bad guy, because when we're using them, in most cases, we're trying to identify an unknown suspect. So through these processes, we can develop a suspect, pass that on to the detective, who can then go grab that suspect, question them, look for further evidence, and it just goes on from there.
What is it that we're looking at here?
A super glue chamber to process evidence. We put the super glue in there and the evidence, and when we turn it on, the super glue is heated and it starts to fume and it adheres to the evidence, and if there's fingerprints on it, it'll adhere to the fingerprints, and then we would dust it afterwards. We put smooth surfaced items in here like cans, bottles, plastic bags. We hang up the bags, of course, and place the other items in here. But you can see the glue is on you can see it on here, how it adhered to the inside of it. If there was fingerprints in there, you'd be able to see the fingerprints, and you could just show it under the light and you would be able to see it.
This here, this is going to be really loud. I'll turn it on for you real quick. Basically, it's a big, huge vent, and it sucks all the powder out, so we're not inhaling it. But, and then you just powder items here, and anything. Oh, this has already been processed. There's nothing on it. So you would glue this because it's non-porous.
Okay.
And then you would take a brush. This is bichromatic powder. It's a carbonate powder. We use bichromatic technically because it's got silver flecks in it, which makes it easier to see. But as you can see on the black surface, it's still difficult to see, so you could use fluorescent. And that enhances it just with a different color. And you would just fingerprint it. And and then you could get into using the ALS and photography, and there's a lot you can do with it.